Function calling is one of the most important building blocks of an AI agent, and you're about to watch it work. Users can't log in. Fix it. One sentence, typed into an agent. Now watch. It pulls the logs, finds the crash, searches the code, patches the file, runs the tests. Green, 12 seconds, start to finish. Now, here's the part nobody tells you. The model that just did all of that cannot do anything. It can't run code. It can't open a file. It can't even click a button. A language model does exactly one thing. It reads text and it writes text. So, what you just watched should be impossible. And it's not just this demo. Almost everything you've ever seen AI do. Searching the web, editing files, querying databases, sending emails, running code, calling APIs. Every single action from every agent on the planet passes through the same narrow door. One mechanism. It's called tool calling. Some platforms say function calling. Same thing. Understand it, and AI stops being magic. By the end of this video, you'll read it, build it, and debug it yourself. I'm Kobe. Let's open the door. Here's the road. 4 chapters. 1. The gap. Why a model on its own cannot act, and the trick that fixes it. 2. The round trip. 1 tool call, step by step, from question to answer. 3. Under the hood. Where calls actually live, why the format never breaks, and how you steer it. 4. Many calls, chains, parallel calls, and the moment tool calling becomes an agent. By the end, that 12-second run will read like plain text to you. Let's go. Chapter 1. The gap. In this chapter, we'll walk through 2 things. 1. The 3 hard limits of a model on its own. And 2. The trick that closes the gap. Section 1.1. Text in, text out. Let's establish what a language model actually is. It's a machine with exactly one interface. Text goes in, text comes out, nothing else ever happens. And that single fact creates 3 hard limits. Limit 1. Frozen knowledge. The model learned from data that ended months ago. Today's stock price, your database, this morning's logs. It has never seen any of them. Limit 2. No hands. Ask it to restart a server, and it writes you a beautiful essay about restarting servers. The actual server never hears a thing. And limit 3. Fuzzy math. A model predicts text. It doesn't calculate. So long multiplication comes back confident and wrong. Frozen knowledge. No hands. Fuzzy math. Hold on to all 3, because tool calling is about to erase them. Section 1.2. The trick. Actions as text. Here's the trick, and it's almost embarrassingly simple. The model can't perform actions, but it can describe them perfectly. So we change the deal. We stop asking the model to do things. We ask it to specify them in writing. A small structured note. Which tool? What inputs? Call it a work order. Tool, get weather. City, Tokyo. That's the whole shape. And around the model, we put an ordinary program called the harness. The harness reads the work order, does the real work, and reports back in text. The model supplies the judgment. The harness supplies the hands. That deal is tool calling. Now let's make it real. Meet Otto, our demo agent. 4 tools: read logs, search code, edit file, run tests. And 1 job today. That cold open you just watched, we're going to rebuild it piece by piece until every step is obvious. Chapter 2. The round trip, also known as the tool call lifecycle. In this chapter, we'll walk through 4 things. 1. The tool list the model sees. 2. The call it writes. 3. Who actually executes it. And 4. How the answer comes back. Section 2.1. The tool list. A tool call starts before the conversation does. When the harness sends your message to the model, it attaches a tool list, and each entry is exactly 3 parts. A name, read logs, a description, fetch recent log lines from a service, use when diagnosing errors, and a schema, the inputs with types, service, a string, required, since, a duration, optional. That format has a name, JSON Schema, and every major AI platform speaks it. Now, the part most people miss. This list is everything the model will ever know about your tools. It never sees your code. It can't inspect your functions. It reads definitions, like a menu. And the menu travels inside the prompt, which means it costs tokens every single turn. Tools aren't wired into the model. They're described to it. Section 2.2. The call. The task arrives. Users can't log in. Fix it. And the model makes its first decision. Answer from what I already know or reach for a tool. It can't see your logs. So, tool it is. Now watch closely, because this is the magic frame. The model stops writing prose and emits a work order. Tool, read logs, service, auth, since, 1 hour. Then it stops, completely, mid-conversation. Look at that service field. Auth. Nobody typed auth. The user said login. The model connected login to the auth service, picked the right tool off the menu, and filled in the blanks from context. That is the trained skill at the heart of all of this. When to call, which tool, what arguments, and then the hard stop, because what happens next is not up to the model. Section 2.3. Execute and return. Time to kill, the biggest misconception in this topic. The model does not run that call. It can't, ever. The model wrote a request and stopped. Now, the harness takes over, your program. It reads the work order, checks it, and calls the real function, your code, on your machine with your credentials. And that detail matters. The model never holds your API keys. It never touches your database or your network. It asked. Your code acted. The function returns 20 log lines, and the harness pastes them straight back into the conversation as plain text. Then it wakes the model up. So say it with me. The model proposes, the harness executes. The result returns as text. If you keep one sentence from this whole video, keep that one. Section 2.4, the answer. And the model simply continues. It reads those log lines exactly the way it reads your messages, spots it, null token, line 9, and writes the answer, found it. Auth crashes when the token is missing. Here's the fix. That's one round trip. Menu, call, execute, return, answer. 5 steps, about 2 seconds. And here's a small recognition moment. Every time your chat app shows using tool or searching the web, this exact dance is running behind that little spinner. You've been watching round trips for years. Now you can see them. Chapter 3. Under the Hood. In this chapter, we'll walk through 3 things. 1. Where tool calls actually live in the conversation. 2. Why the model gets the format right every time. And 3. How you steer when it calls. Section 3.1. It's all one conversation. Strip away the product, and every conversation with a model is just a list of messages. And Here's the honest secret. A tool call is just another message in that list. The call gets appended as an assistant message. The result gets appended as a tool message. And then, this is the key. The entire list goes back to the model for the next turn. Because a model is stateless, it stores nothing between calls. It doesn't remember the tool call. It rereads it every turn, the whole transcript from the top. And that one fact explains two things builders learn the hard way. Tool results eat your context window because they never leave the transcript. And a tool that returns 10,000 junk lines doesn't hurt you once. It hurts you on every turn that follows. Tool calling isn't plumbing on the side. It's all one transcript. Section 3.2. Why the format never breaks. So, why is the JSON always valid? Because it's trained, not hoped for. In the early days, you begged in the prompt, please respond only in JSON. Then, you parsed whatever prose came back and prayed. It broke constantly. Native tool calling ended that with two moves. Models are fine-tuned on millions of examples of choosing tools and writing arguments. And the API constrains the output, so the call you receive is guaranteed to match the schema, guaranteed to parse. But hold on, valid is not the same as correct. The model can still send a file name that doesn't exist or an ID it half remembered. The structure is guaranteed. The truth is not. Which is why a serious harness validates every argument before running anything. The schema checks the shape. You check the facts. Section 3.3. Steering the calls. One more control most people don't know they have. Tool choice. 3 positions. Auto, the default. The model decides tool or no tool. Required. The model must call. That's your pick when you want structured output every single time. And none. Tools off, plain text only. And notice what auto really means. A good model also knows when not to call. Ask it what a null pointer is, and it should just answer. That's knowledge, not action. Ask it whether login is still failing, and it should reach for the logs. Restraint is part of the skill. A model that calls tools it doesn't need is burning time and tokens. Chapter 4. Many calls, also known as chaining and parallelism. In this chapter, we'll walk through 3 things. 1. Chaining calls that depend on each other. 2. Running independent calls in parallel. And 3. The small step from tool calling to a full agent. Section 4.1. Chaining. Remember the cold open? 12 seconds, bug to green tests. You've now earned the slow motion replay. Call 1. Read logs. The result comes back. Crash, invalidate token. And that result changes what happens next. The model rereads the transcript and decides. Call 2. Search the code for validate token. Result, a file path, which becomes the argument of call 3. Edit that file, then call 4. Run the tests, green. Look at the shape of that. Each result feeds the next call. That's a chain. And notice what's missing. There is no flowchart, nobody scripted, logs, then search, then edit. The model redecided after every single result. If the logs had shown a database error instead, the chain would have bent that way. That's what makes this flexible. And that's what makes it powerful. Section 4.2. Parallel calls. Sometimes, though, calls don't depend on each other, and a modern model can write several work orders in a single turn. So, quick test. Auto needs 4 things. Read the auth logs. read the payment logs, search the code for whatever the auth logs reveal, and run the tests after the fix. Pause the video and decide which of those can fire together. Ready? The two log reads. They're independent, so they go out in one turn side by side, but the code search needs the auth result first, and the tests need a fix to test. So, two in parallel, then a chain. That's the whole rule. Independent work runs together. Dependent work waits its turn. Open any agent trace, and you'll see that rhythm everywhere. And now you know how to read it. Section 4.3, from tool calling to agents. And now, the bridge. Take the round trip and run it on repeat, pointed at a goal. Call, result, reread, decide, call again. Stop when the job is done. That loop has a name, an agent. That's the entire secret. An agent is not a new kind of model. It's the same round trip you now understand in a loop with a goal. Real agents add more around this loop: memory, planning, guardrails, but the engine at the center is exactly what you now understand. Let's lock it in. The gap. A model only reads and writes text. Frozen knowledge, no hands, fuzzy math. The trick: it writes work orders and the harness executes them. The round trip. Menu, call, execute, return, answer. And the model never runs anything. It proposes. Under the hood, calls and results are just messages in one transcript. Reread every turn. The format is trained and guaranteed, and valid still isn't true, so validate. Many calls. Chain what depends. Parallelize what doesn't, and loop it with a goal, and you've built an agent. There's the cold open again, full speed, 12 seconds, and this time you can read every line. That's tool calling, the one mechanism between a model that talks and software that acts. That's it for today. If you learned something, drop us a like and subscribe. There's a lot more where this came from.